You can't print a rupee note on normal paper because the paper is the security. Inside an Indian currency paper factory, the real story isn't ink or design. It's the moment raw fibers are turned into a sheet so engineered that a tiny flaw can destroy an entire batch. Too weak, it tears. Too absorbent, the print bleeds. Too smooth, the ink won't grip. And if the embedded features aren't perfect, it's rejected, no excuses. This is where rupee notes begin, not as money, but as a controlled material built to survive years of folding, sweat, heat, and handling, while fighting counterfeiters at the same time. You'll see fibers prepared and refined, watermarks formed inside the sheet itself, security threads embedded mid-flow, and massive drying and finishing lines that produce paper consistent to the micron, under strict access and non-stop quality checks. Stay with me, because once you see how currency paper is made, you'll realize the note in your pocket is protected long before the first drop of ink ever touches it. Banknote paper doesn't begin on a machine. It begins with something rough and humble, cotton fiber. And what ruins an entire batch isn't fire or a blade. It's a strange smell, one wrong moisture point, a speck of contamination smaller than a grain of sand. So we don't procure raw material here. We trap risk with long-term contracts, ruthless incoming specs, and a batch code issued before the supplier's stock even moves. COA, transport documents, sealing records. When that file closes, the real story opens at the security gate. The truck stops. Nobody rushes. But everything is racing. Warning lights blink. The barrier stands like a steel verdict. And the most important thing right now isn't weight. It's the number on the seal. One mismatch, one scratched seal, one missing digit can turn the entire load into a suspect. A camera clicks. Time gets stamped into the trail. Then the truck is guided into a one-way route, like entering a corridor with no reverse gear, straight to the weighbridge. This vehicle carries tons, but this factory lives and dies on a few kilos of deviation. Tires roll onto the scale, the digits jump, and in that instant, the load stops being a delivery. It becomes a batch ID, a name that follows it like a shadow. The receiving slip prints out with a dry rattle, almost like an oath. From here on, every hand, every decision, every second leaves a trace. The batch ID goes into the electronic trail. Only when security conditions lock in does the system give the one permission that matters: unload allowed. Cutting a seal isn't opening a door. It's pulling the curtain off the truth. Two people stand shoulder to shoulder, two-person rule, because one lone hand is how blind spots are born. The seal snaps with a hard tack, and the air hits first, damp, stale, chemical, off. That smell can kill a batch faster than any machine fault. Quick tests, visual checks, torn bales, wet patches, mold stains, dirty marks. One suspicious bale is isolated without drama. The approved ones move on into the controlled chaos of the debailing zone. This is where a bale becomes what it truly is: a cloud that can be corrupted. Industrial dust extraction roars like a small storm. Fiber is torn open, clumps broken, coarse waste shaken out by mechanical screens. Trash doesn't vanish. It gets collected, tagged, and pushed into a separate fate. Each charge is weighed because too much or too little doesn't just waste material, it creates instability. Then the fiber drops into the feed hopper, soft sound, light fall, and the countdown begins towards the most brutal conversion step: pulping. Cotton enters the pulper as fiber. Minutes later, it's a white, churning slurry. Motors growl deep, the tank trembles, and the operator isn't watching for nice flow. He's hunting one invisible enemy: lumps. One non-uniform pocket today becomes a surface defect tomorrow, and that defect can haunt the whole run. Mid-batch samples are pulled, warm, heavy, smelling of fiber and water. Uniformity is confirmed. Then, the pulp moves through sealed piping into the dark network of the plant, where contamination is about to be hunted down layer by layer, multi-stage cleaning. This isn't filtering. This is a purge. Screens shake and rattle as oversized particles get trapped with a cold, mechanical certainty. Then comes heavy light separation. Grit sinks, metallic dust drops, light contaminants are flung away. No second chance. Waste travels on its own line like a convoy of expelled trouble. But this factory doesn't trust intuition. It trusts samples. Post-cleaning checks confirm cleanliness against plant standards. Only then does the pulp earn the right to move forward, into a phase where clean is no longer enough. Now it's about fiber structure. Fiber has behavior. Some fibers resist bonding, some break too easily. Refining is where the plant disciplines the fiber with controlled force, controlled timing, controlled rhythm. The machine runs steady. Metal on metal carries a warning in its sound. Push too hard and you damage the fiber. Go too gentle and the sheet turns weak and unreliable. Internal tests track fiber bonding and flow behavior like checking a patient's pulse. Final filtration. Batch trace is locked into records. And the pulp steps into another high-risk moment, blending, where one wrong ratio can destabilize the entire line. Blending isn't pouring things together, it's precision orchestration. Approved pulp batches enter the blend chest by verified ratio. Slow, heavy agitators turn like the wheel of fate. Consistency must hold because fluctuations don't just change paper, they imprint mood into the sheet. Lab checks confirm baseline parameters. No showmanship, only truth. When the batch is released, it isn't a formality, it's a verdict. This pulp is fit to become banknote paper. Then it's pumped to the head box, where the sheet is born on a moving wire. A sheet isn't born with a bang. It appears as a thin, wet web, spread across the forming wire in a heartbeat. Water drains away. The surface begins to take shape. And the online cameras don't blink. Holes, tears, streaks, weak spots. Anything here becomes a permanent signature later. The web runs forward like a living skin still learning its strength. Speed and stability are logged. Tension is controlled. But before this web is allowed to go further, it must pass through a zone where even air feels heavy, the paper security control area. Some sections of this plant are not restricted for drama. They're restricted because one mistake becomes a breach. Access cards, cameras, two-person oversight. Everything sensitive, if present, is logged under the same batch ID that started at the gate. Internal cross-checks happen before the web is cleared to continue. No assumptions, no shortcuts. Then the web moves through a closed route to the next battlefield, where it will be squeezed until it almost can't breathe. Press dewatering. The wet web enters the press section like stepping into a jaw. Rollers close in. A steady thump-thump rhythm fills the space. Water is forced out and captured back into the plant's circulation. Nothing wasted, nothing uncontrolled. But pressing isn't only about dryness. It's about strength, forcing fibers to lock into each other. Online sensors read moisture after press. Guidance systems keep edges aligned, because a tiny drift here becomes a disaster at cutting. The web exits stronger and heads into heat, steam, and relentless motion, the dryer cylinders. Steam rises. Dryers hiss. The sheet runs across cylinder after cylinder, zone after zone. The fight here isn't dry it fast. The fight is dry it right. Too fast and the sheet warps. Too slow and residual moisture invites deformation. And worse, future spoilage. Cameras scan for folds, wrinkles, edge tears while the line is moving at speed. When the web reaches the end and the roll is marked accepted, it feels like relief. But it's not the end, not even close. The surface still needs to be locked down, in finishing. Surface is reputation. One rough patch, one thickness variation across the width, and the sheet will expose every weakness later. Finishing stabilizes texture and uniformity. Calendaring smooths and evens thickness in controlled passes. Online gauges scan across the full width like a radar sweep. Defects are marked without argument. Precise location, precise record. Then the paper heads to the most hypnotic stage of all. The stage where it stops feeling like a roll and starts looking like money. Cutting, stacking, bundling, sealing, vault storage. If you want to understand what discipline looks like in physical form, watch this. Blades run with a hard, confident rhythm. Sheets drop perfectly, and automated arms square each edge like lining up a regiment. Stacks grow taller, sharp corners, clean faces, until they look like giant blocks of cash. They're pressed, weighed, cross-checked, photographed, tagged. Faulty sheets are blown out without hesitation. Bundles are built like brickwork, layered, protected, sealed, labeled, released, like a final court order. Then come security boxes, tamper seals, scanned seal IDs, and a 2-door vault transfer. Outer door closes before the inner door opens. No gaps, no soft moments. And finally, the specialist vehicle rolls out of the gate, silent and heavy. The process ends here on paper, but the mission, protecting value, has only changed location.
We have a brief deviation on P14. Adjusting the flow rate now.
Copy that. Looks stable from here. much.
Aligning on the mark. Stand clear of the barrier. Easy back, easy. Hold it right there.
That's the one. Right there on the line. Okay, clamp it. Keep the tension steady on your side.
Looks good. Clearing the last guide now. Alignment looks good on this side. Confirmed. Tension holding steady.
Thank you for watching the video, and please subscribe to my channel. And what production process would you like to see next?